Hello, I'm Katie Kennedy, and today I'm going to be discussing the hydroclimatology of the greater Yellowstone region and how it contributed to the recent floods in just this past June. I definitely don't have enough time to cover all the climatological factors that are affecting the hydrology of the region, but I've chosen a few items that I think most relate and also relate to our material this semester. This cover photo is actually a picture I took when I visited Yellowstone National Park at the end of April/early May. And I have some more personal media that I'm going to share later. This is the Morning Glory pool that can be found in the Upper Geyser Basin in Yellowstone National Park. So I actually live in Virginia, and I'm not super familiar with a lot of water shortages or too much change. We've had some change in climate here in Virginia, as has the whole world. But what exactly drew me to from Virginia to talk about Yellowstone? Well, as I mentioned, I visited the national park recently, and I had the adventure of my life. And it was just weeks before the floods. I think I left like one of the last days in April, April 25th or 26th, and came back home May 4th. And it was just amazing. I'm so grateful that I got to see so much of the park, and I got to see it before these floods hit. But it really like pointed out how many natural gems and some endemic species and just a lot of nature in its prime found there, which is sad when I think about the floods and the effects of hydroclimatology, the climate changes going on. Excuse me. Um, but yeah, it's just super sad to think about it. I actually felt physically ill when I saw the floods because my love for the park was still so fresh when it happened. I actually happened to go 1 week before the spring season opened. So there was a few things that weren't open, but not anything crazy. We were going around the clock from 6 a.m. until midnight every day. And it there was a few things that weren't open, but I did go to Mammoth Springs, which is kind of near, is it Granier? I think it's called Granier. I might not be saying that right. But it's at the north entrance of the park where the Roosevelt Arches are. And that's actually one of the areas that experience one of the greatest amounts of damage. Um, but it actually snowed a lot while we were there, which was super cool. And some of the trails were even like stacked up with snow so much that we could, the snow line was actually at the bottom of the trail signs. So that was pretty crazy. But I read some articles talking about excessive precipitation during the winter months, which led to a lot of the runoff that helped cause these floods. I got to talk to a wolf research team, and they let us look through their scopes. And I saw grizzly bears, marmots, the pronghorn, elk, wolves, so many different types of birds, coyotes, bighorn sheep, moose, and of course, as everyone knows Yellowstone, the bison. We were so excited when we first got there. We were taking pictures of all the bison, and by the time we left, we were like, oh, it's just a bison, just another bison. But it was really cool. I got to go on a tour through the Tetons, which was awesome. And we drove through Idaho to get there. We did a little hidden hike, and that's where the snow was stacked up so high. So I really got to see a large portion of this area, and I liked it so much. I just wanted to learn more about what caused the problem with the floods, and did they know it was coming, and what can we do to save it? So I threw this slide in here for just a general basis of what exactly hydroclimatology is, which we've been learning about all semester. But it's just how the climate system reacts with the hydrologic cycle and on a spatial and temporal scales. So you're looking at precipitation patterns, temperature patterns, what geography is around that could come into play with climate change. And essentially, you take longer periods, like a norm is 30 years, or you compare decades, and you get a running annual average, and then you can make trend lines and compare data which is kind of what I do at work also. I work in water quality lab. So we look at things like rain events as it compares to water quality, turbidity, bacteriological counts. So, I mean, looking at trend lines is really common in science, and it was really interesting to learn about all this through class. So yeah, we just basically want to look at how these changes are affecting everything, the ecosystem, human life. How is it? Is it increasing? Is it decreasing? How fast is it happening? So yeah, it's really interesting. It's been really interesting to learn about. So I titled my project about how the greater Yellowstone ecosystem or the greater Yellowstone region has been, uh, how the hydroclimatology of that entire area contributed to the floods. But originally, when I started looking into it, I just looked up Yellowstone National Park. And as I started looking into the hydroclimatology and the climate studies that have been done and the assessments, I realized that there's a lot of things that come into play in that region. I mean, you can see here on this map, we've got Yellowstone National Park is shown here in the dark green in the middle, but all that light green around it is considered the region. And so Yellowstone Park is 2.2 million acres, and the whole greater Yellowstone ecosystem, which is how it's been classified by researchers, is anywhere from 12 to 22 million acres, which is wild. Um, so yeah, usually you hear people talk about Yellowstone and they're talking about the park itself, but there's a lot more to it than that. There's a lot of land that's used for different things. There's some five national forests, three national wildlife refuges. There's some government-owned areas, tribal and private lands. And a lot of it's really high elevation. I actually had trouble hiking on some of our hikes. I did not put the picture of me struggling in this presentation, but I thought about it for a laugh. Um, but I certainly could tell that I was in a higher elevation than I'm used to on the East Coast in Virginia. And just driving and looking at the mountain ranges, the Rockies, it was just, I mean, that's kind of stuff just makes you feel small. But these are all things that come into play as climate change affects areas. So here's a slide that shows the topography and the different watersheds that actually kind of meet where the park is. As you can see here, I did my best to estimate the general area that this watershed photo shows. I just went into Google Maps and kind of just drew a few lines real quick. But it kind of gives you the general idea. Here, you see a bunch of dry, flat areas up in it's this watershed. And here's the Yellowstone River. And I believe, let's see, the north entrance would be somewhere right up here. And so that water comes rushing down from not just this flat area with not a lot of growth, but also these are all mountains, really high mountains. I mean, they're huge. So I did my best to kind of show, how topography comes into play. And I didn't see, I mean, I know they broke a lot of records. I'm surprised that they haven't had more flooding, but I guess the area just, uh, this is like a pluvial, just so far out of the norm for what the area generally receives as far as precipitation goes. So a little bit about the flood that happened this year. It happened on June 13th, 2022, and it was mainly the Yellowstone River and its tributaries, but the entire region was affected. They had 200% more moisture than usual, which is wild. Certainly a pluvial. Now, granted, I say pluvial. I guess a pluvial probably more may refer to one event, but their soil moisture was already so high. And I'll show you a slide of that later. But the record flow rate was previously set at 32,000 cubic feet per second, and the new flow record now is 50,000 cubic feet per second, which is crazy. The water level was 2.5 feet higher than all the records over the past 130 years. And this, like I said earlier, this was a combination not just of heavy rainfall, but also increased snowmelt because they had more precipitation through the winter months. They had more snow, so as the spring season came sooner, it was warm, and all that happened at the same time. It was like a perfect storm. Um, this video here, I saw this on the news and it just struck me. So I'm going to play it for you. See how this works.
That is insane.
So this is a um, hydrograph from USGS, and it shows just how fast the water really came up. So you can see there on Friday at 2 p.m., it just shot up all the way up to that red line and came down, fairly quickly as well. But this kind of shows I read one study. It was the Greater Yellowstone Area Assessment, and they predicted this was actually submitted in 2021. So they were already predicting things like this to happen. They've been studying the area, but they've been, predicted increased annual precipitation about 7% by about 2041, and increased precipitation between the months of December and April, which kind of actually lines up with the increased snowfall that they had during this event that contributed to the flooding when it melted. Um, and so they also talked about the origin of precipitation and the season and the topography and how it affects the totals. During the 21st century, they had the largest increase of precipitation during spring months. And so, as I've already mentioned, more precipitation is more snowpack, which melts, once it warms, and it causes a lot more runoff. And this was actually caused from an event from the Pacific side. So here's some data that I got from the GYA, Greater Yellowstone Area Climate Assessment. And this just shows the precipitation in the different watersheds. You can see in the upper middle, let's see if I can get my laser going. Here we go. So upper Yellowstone, which is the area where the floods happened, that's kind of what I was focusing on, although all of these areas seem to kind of have a general upward trend in the amount of precipitation. And this is from, so it's the current year is about where my laser is. Okay, sorry, I'll put it upper Yellowstone. The current year is about here. So these previous black lines are past precipitation, and the red and blue are the predictions. And then there's a little bit of variance calculated in there as well. But they're all on a little bit of an upward trend. And while it might not seem like much, as we've learned, it doesn't take much to make a big difference. And then this actually shows the, you can see the percent change here. So let's see, here's the Yellowstone, upper Yellowstone. So where's our year? They're 5% change from the year 2021 to 2040. And we've already clearly seen that and contributed some pretty big data to this prediction. So I really liked this picture. I mentioned it earlier that the soil moisture levels were a lot higher. Um, so here is our two maps. One shows 2021 and one shows 2022, and they're about the same time of year. And as you can see, it's for the greater Yellowstone area. It's got the whole area and then the parks here. So down here's the soil moisture anomaly. And as we've learned, an anomaly is a value, it's like an average taken over time. And so it can be positive, which means it's higher. So this would be the mean. Positive meaning it's higher than the average, and negative meaning it's lower, and by how much. And you can see just from 1 year the difference that this had. So this is just, these types of changes are unpredictable. I mean, who would have thought this would happen? But as climate change is occurring, that's the problem. These things are becoming more and more unpredictable. And the way that water reacts to climate change is, I mean, it's really important for what we can do to keep people living the way we live today. So in the same study that I looked at earlier, the Greater Yellowstone Area Climate Assessment, they also had temperature data. So I was trying to kind of copy what we've been doing in class, compare some means and values of temperature and precipitation data. And as you can see here, these are all also on an upward trend with the same year range. And you can see here, this correlates, the upper Yellowstone area correlates with the precipitation. The precipitation was also increasing over, from the average. And here you can see all of these values are positive, and all these general trends are positive correlations. So over time, precipitation and temperature are both increasing, and that's a problem. So since I just went to Yellowstone, I wanted to share some of my personal media. So I took some videos as we were flying in and driving, and I really just kind of wanted to share these just to give you an idea of what it's like out there. As you can imagine, you see, I mean, these are still shots right now, but here's a mountain, so the way that water hits, all that water runs off. So heavier rainfall is going to come down and run down and send more and more water down in these lower areas. And you can see there's lots of hills and little crevices and lots of just a lot of geography that contributes to damage from increased precipitation. And increased precipitation is has a positive correlation with rising temperatures, and all that is coming from climate change. So this is actually, the Yellowstone River, let's see, shoot, let me back up. So the Yellowstone River is actually running right here. I was driving to a hot spring in this video, and I just wanted to point that out because this was the region that people, that got the most attention, because that's kind of where the headwaters of the Yellowstone River meet the park. Now I'm not in the park in this photo, but yeah, the river is certainly, I can't, I think it's right here. Maybe it's right over this bend. But it was beautiful out there. Let's see, here's another one. This one is while we were flying into Bozeman, Montana. So look at all those hills and all those little areas where water will just run off and then, go go flowing whichever direction the natural slope will take it. So these are two still shots that I took. On the left, this is the lower falls of the Grand Canyon of Yellowstone. Um, this may not look amazing and large. I mean, it's a beautiful photo. I'm actually standing. This is called Artist Point, and it the water was not high at this time. I mean, the temperatures were cool. They had a fair amount of snow, but I don't think there had been enough snow melt at the time to really bring the volumes of water very high. But I mean, as water hits all these big mountainous regions, it just continues to flow down. And then as that water rushes through, not only does it destroy homes and towns, but also the local topography. It'll dig out holes and crevices along the river bend. It's just not good all around to have unnatural volumes of water. On the right, this is the Snake River, and as you can see, that's why it's called the Snake River. I was just imagining as this river rises how I mean, this area might just disappear and this might turn into a little like lake area. So just some things I wanted to kind of show that I took the photos, I was there, and I could see how the hydroclimatology of the region changing could affect it in a really bad way. So I know I showed you a lot about the geography, topography, and the data, but I really did want to also show some of the wildlife in Yellowstone because these are the guys that are really going to be struggling. And a lot of these species, I mean, there's not a whole lot of, you don't see moose everywhere. This is my first time seeing a moose. Now, I mean, I live in Virginia, but I do know we got to see the pronghorn, and I did study them a little bit leading into my trip. And it's a very unique ecosystem for them. It would just be detrimental, and they might not make it if that ecosystem is destroyed. So this is a sweet little moose I saw. Doesn't have as I guess they shed their antlers. I didn't know that, but now I do. Just eating this grass, or her. So this is actually this bear. Our tour guide told us that she thought he was coming out of hibernation. He or she or they were coming out of hibernation. And it's not so much in this video, maybe a little bit, but the bear kind of looked a little drowsy, like he'd been sleeping for a long time, and super cute. We watched this one for a long time. I just took a quick little clip just to show you. And then this elk, I just lost it when it scratched. You'll see. Ah, it's scratching itself like a dog. So cute. It's just important to remember and connect with these species who rely on the water and the ecosystem to remain the way it is. And it really makes you feel, the desire to spread the word about how important it is. So with all that said, I'm going to wrap it up. Some things I thought about that I didn't really mention. A lot of wildfires happening, and that also affects runoff, increases runoff. I saw a lot of burn areas, they look like natural burn areas throughout the park. And the geysers, how are the geysers going to be affected? Water availability and quality are both affected, and everyone needs it. The wildlife, humans, we rely on, we need it to live, we need it for recreation. And the shifting climate patterns are just starting to have a really grave effect on some really natural gems. And I hope that we can all take what we're learning in this program and put it to good use and educate others and hopefully try to make a difference. I hope you enjoyed this. And there's one last slide with my citations. And take care. Thanks.